We'll discuss more on the frames.
This conference will now be recorded.
So in 1 second, guys, give me a second. Okay, the story is something like this. So we will concentrate on how it is working out. So we will concentrate more on the frames part. So I have a frame. This has subframes, which has time slots. This is time domain. This is time domain. Means data is put in every subframe. Means data is pumped in for every millisecond, 1 millisecond. That means data chunks are pumped for every 1 millisecond in some given bandwidth. Right? So hope you understand what I'm trying to say. So that means, so I have some data packets, 1000 bytes. I'll put 200 bytes or 100 bytes here, 200 here, 200 here, 200 here, 200. Means for every 1 millisecond of time. Okay, this time part is called as subframe. 1 millisecond time is called as subframe. So subframe is a time domain part. Okay, this time domain part is okay. So 1 millisecond of time with respect to 20 megahertz of bandwidth. So 20 megahertz of bandwidth is used for 1 millisecond of time. It is called as one subframe. Okay, so time part is called as or time wise we call it as a subframe. So in the same way, what we have is okay. So we have SFs. So this is one SF. This is one SF. This is one SF. So on. So we have subframes. So each subframe is further divided into 0 and 1 time slots. So this time part we have seen. In time part we have the last part is time slot, which are 0 and 1, whose duration is 0.5 milliseconds. Okay, so we have subframes which are 0 to 9 and whose time part is from 0 to 9 milliseconds, and we have frames part which is 0 to 1023 which are from uh, okay. So whose duration is I cannot count the duration. You can count the duration. So you can multiply 1023 into 10 milliseconds. Is the duration of the total duration of this particular part. So, but one frame duration is 10 milliseconds. So subframe duration is 10 milliseconds. Sorry, 1 millisecond. This is 1 millisecond. This is 10 millisecond, and this is. So this is all time domain we have seen yesterday. Okay. So now let us concentrate on the frequency domain part, which is the most important part. So in the frequency part, okay, I take one subframe. So now this subframe contains some waves. So these waves are called as subcarriers. So there are totally how many subcarriers? 1333 subcarriers. Okay, so where each subcarrier is of 15 kilohertz. Where each subcarrier is 15 kilohertz. Okay, so now, so now what we are trying to do is, okay, now basically what we are trying to do is, okay, so now basically what we are trying to do is, so we have these subcarriers. Okay, the subcarriers is nothing but as today already told you about the frequencies, the concept of frequencies, okay, ranges, bandwidth, everything I told you yesterday, right? So we have so bunch of frequencies combined together, okay, between any range, okay, so between any range, between 1920 to 1940, or you can say 2520 to 2540, anything, okay, any range of 20 megahertz of bandwidth, okay, some frequency waves you are taking. So in this wave you are sending the bits, data bits, right? So now what we are trying to do is, so now each again, so each okay, so each wave we are taking it, okay, again this, okay, it's again the subcarriers bandwidth I'm saying it as 15 kilohertz, means again they are bunch inside this, again there's bunch inside this, okay. So but whatever it is, the minimum bandwidth we are taking it as 15 kilohertz. That means we are taking, okay, so some bunch, so very, actually they are very minute frequencies, okay, my frequencies are very minute, but we are taking a bunch of 15 kilohertz, okay, so and we are calling this bunch as one subcarrier, okay, again some bunch of photons, okay, which can carry data, which are oscillating, okay, we are again calling it as one subcarrier. So and again I'm saying 15 kilohertz of subcarriers. So whatever it is, so now I'll take these kind of, okay, 12 out of okay, I'm starting from 1 to 1333. So I'm taking 1 to 12 subcarriers. How many? 1 to 12 bandwidths. Okay, I'm calling it as one RB. RB is nothing but resource block. RB is nothing but resource block. So that means what I mean to say is this is frequency domain. So in frequency domain, okay, in frequency domain, we are having, okay, we are having one, okay, totally we are having, so two time slots, okay, in one time slot, so I'm taking totally, I'm having 20 megahertz of bandwidth. So 20 megahertz of bandwidth, okay, can have 1333 subcarriers. So where each subcarrier bandwidth is, so where each subcarrier bandwidth is So each subcarrier bandwidth is 15 kilohertz. Okay, so these waves. Okay, we are considering how many waves? Okay, 12 waves or 12 subcarriers. I'm calling this as 1 RB. So 1 RB is nothing but one resource block. Okay, I'll tell you the whole story. Okay, I'll tell you the whole story why all these things is. So now, okay, basically, okay, so now there are a lot of questions to be asked. Okay, the first question is, okay, in the frequency domain, okay, why we are taking 20 kilohertz? Okay, I'll ask you some questions. The first question is, why only 20 megahertz? Okay, why only 20 megahertz? Second question, okay, why only 15 kilohertz of subcarrier? Okay, why only 15 kilohertz of subcarrier? Third question, okay, so why only 12 subcarriers we are taking as a group and calling it as 1 RB? So these three questions has to be answered. Okay, so the answer for first question is, okay, so why only 20 megahertz? Okay, because this is a limitation from, give me a second guys, give me a second. Okay, so there are three questions which has to be answered. The first question is why 20 megahertz of bandwidth? So this is a limitation. Okay, this is a limitation from the bands we are getting. because the problem is available bands we are having is, okay, we are having some bandwidth of 1920 to 1980. So if I share among three operators, if I share among three operators, right? So then I can share from 1920 to 40 for one operator, and 1940 to 1960 for one operator, and 1980, okay, 60 to 80 for one operator. So this is a limitation what we are getting from the bandwidth itself. Okay, so we cannot make any changes in this part, and this has been already decided by the 3GPP. So for increasing the bandwidth, so we are considering it in 5G. Okay, so for increasing the bandwidth, we are considering it 5G. So this is the limitation we are getting it from 3GPP, you can say. Okay, so this is the limitation from 3GPP. The second question is, okay, bandwidths, okay, band of 20 megahertz is fine. Okay, that's great. So now, why 15 kilohertz subcarrier? Okay, so the problem is why 15 kilohertz subcarrier is, okay, basically when you pump any data is pumped in the form of what? In the form of bits. Data is pumped in the form of bits. Okay, for pumping one bit, at least you require a bandwidth of 15 kilohertz. How much? 15 kilohertz of bandwidth is required for pumping at least one bit. Okay, so for pumping one bit, we generally require 15 kilohertz of bandwidth. So here what we have a concept is, here we have a concept of, okay, so we have a concept of some resource elements. So we have a concept of resource elements. Resource elements means, okay, what I can say is, so I have a total bandwidth of how much? Total bandwidth of 20 megahertz, right? A total bandwidth of 20 megahertz. Okay, what is the time duration? 0.5 millisecond and 0.5 millisecond. So I have a limitation of 0.5 millisecond and 0.5 millisecond is the limitation what I have it. So now what I am trying to do is, okay, so now here I am again further dividing the 0.5 into 7 parts. How many parts? How many parts? This 0.5 I am dividing into 7 more parts. This 0.5 again I am dividing into 7 more parts. So each part I am calling it as symbol. Okay, each part I am calling it as symbol. This is called as OFDM symbol. This is called as OFDM symbol. So now one time slot can have how many symbols? 7 symbols. One subframe has how many slots? 2 time slots. 2 time slots means how many symbols? 7 plus 7 means how many? 14 symbols. Okay, so how many symbols? 14 symbols. Okay, so now, so 14 symbols is time wise again. Again, this is time wise. Okay, so the least part is symbol, then slot, then subframe, then frame. Right? Symbol, slot, subframe, then frame. Okay, so now I am drawing one subcarrier frequency wise. This was time wise. Now frequency wise, this I am saying the bandwidth of how much? 15 kilohertz. Okay, so now in one symbol for 15 kilohertz of bandwidth, I can pump 6 bits. How many bits? How many bits I can pump? 6 bits. Okay. Bandwidth wise, how much it is? 15 kilohertz. So this I am calling it as subcarrier. Time wise, I am calling it as symbol. Okay. So now this symbol and bandwidth part, now I am calling this whole thing as one RE. I am calling it as one RE, resource element. So one resource element can carry how many bits? 6. Okay, I am repeating again. It's a very complex process. So once again I am repeating, the story is we are trying to pump the data from E node B to, okay, we are trying to pump this is what you have to understand very carefully, and this is a very top entry question in the interviews. Okay, Qualcomm people generally ask this. There is one guy, Chenmai, okay, he cleared his interview in Qualcomm using this entry question only. Okay, so now the thing is, the story is something like this. So this is the base station. This is the UE. UE is pumping some data in terms of frames in downlink and pumping the data in terms of frames in uplink. So a frame consists of two domains. One is time domain. Second one is frequency domain. Okay. So the data is going down in frames, right? In uplink or downlink. Data is going down in uplink or downlink in terms of frame. A frame contains two domains, frequency and time domain. So in time domain parameters we have seen, okay, a frame, okay, a frame which is nothing but is called as SFN, okay, whose duration is 10 milliseconds. Okay, so which contains 10 subframes. So one subframe duration is 1 millisecond, which contains 2 time slots. Now one time slot duration is 0.5 milliseconds, which contains 7 OFDM symbols. Okay, now so 7 OFDM symbols. Now one OFDM a symbol. This OFDM a symbol can carry how many bits? This is okay. So whose duration you can calculate it? So it can. This is what is time wise, right? This is time wise. So but actually time and frequency combo only can do this. Okay, it cannot only time can do all this work. Time plus frequency. It is always x plus both axes. Okay, this is time part. Any questions on this?
Hello.
One word PMA means one resource element.
One FDM means
One resource element.
yes. One FDM contain one resource.
The maximum is 256 cam.
Then at that time we use 8 bit.
But as per specs, it is 60%. As it, for that, we are using alt CQI table. 6 bits is fixed in one symbol. No, it is not fixed. It is 2, 4, 6, 8. Okay, but as of now, I'm taking 6. Okay, this is time domain. Now I'm talking with the same. Okay, now out of this frame, I'm taking one subframe. Okay, out of this time, I'm taking one subframe. In this subframe, okay, so now out of this time, I'm taking one subframe. So in this one subframe, okay, or the whole frame, anything you can say. So now I'm talking about the frequency part, or you can say the whole frame. Okay, so now I'm talking on this part, frequency part. So till now we are talking on time part. Now I'm talking on this part, frequency. So in the frequency domain, okay, so the maximum bandwidth is 20 megahertz. So here time domain, it is milliseconds. Measure is in milliseconds. Whereas in frequency domain, it is in hertz, megahertz, 20 megahertz. So which is divided into subcarriers. Each subcarrier is 15 kilohertz. So 15 kilohertz is the smallest element. Okay, so further we have 12 subcarriers is equal to 1 RB. Okay, 12 subcarriers is equal to 1 RB. So 1 RB contains 2 slots, 7 OFDM symbols, time domain. So 12 subcarriers, frequency domain. So it is 12 subcarriers, frequency domain. So this whole combo is called as 1 RB. Okay, so now one subcarrier's one OFDM symbol is called as 1 RE. 1 RE. So this part, only one, means 7 symbols, 12 subcarriers. 7 symbols time wise, and 12 subcarriers frequency wise. This combo is called as, okay, this time wise, this frequency wise is called as 1 RB. It's called as 1 RB.
Only 7 symbols or 7? Okay.
One slot 7, 2 slots 14.
In slot.
Means RB is only 7 symbols and 12 symbols.
Yes. RBs are calculated per time slot. One time slot can contain 7 symbols, right?
Short circuit.
But 0 and 1 time slot. So 7 symbols in 0, 7 symbols in 1.
Yes.
So means one time slot will form 1
1 RB.
RB with 12 symbols.
Yes.
Two time slots form PRB.
Yes. Okay. So so now this part is called as one RE. Okay. So one RB contains how many REs? You tell me. One RB contains how many REs?
12 into 7.
84 REs, right? So it is 7 or 40.
7.
80, sir.
So now one RE is nothing but, yeah, yes. So one RE is nothing but, one resource element is nothing but, okay, one RE is nothing but time wise one symbol, time wise one symbol, frequency wise, okay, one subcarrier. Okay, this is called as one RE. Okay, so this is how it is working out. So RE, so we have to take both, okay, frequency and time domain. So that means, okay, so that means, so what we can say is, okay, the whole conclusion is something like this. The whole conclusion is I'm trying to wrap up things. In frequency domain means in this domain for a given subcarrier or for a given uh, subframe, sorry, for given time slot. Okay, so you can say this is time domain, this is frequency domain. So we are talking on the frequency domain. So in the frequency domain, so you can have the maximum bandwidth. So you can take it as 20 megahertz. And second one is subcarrier bandwidth, which is nothing but 15 kilohertz. So these are the two things which we consider it in frequency domain. So in frequency domain, we take subcarriers and total bandwidth. Now combo of frequency and okay, now we are taking, okay, so once again I'm repeating. So in frequency domain, total bandwidth, sorry, not maximum bandwidth, total bandwidth and subcarrier bandwidth. Okay, total bandwidth is 20 megahertz and subcarrier bandwidth is 15 kilohertz. Okay, only two things exist in frequency domain. Okay, in frequency domain, two things. Okay, one is total bandwidth and one is subcarrier bandwidth. So subcarrier is 15 and total is 20. And we can have, okay, for 20 megahertz or for total bandwidth, we can have 1333 subcarriers. Divide it, you'll get it. 20 megahertz by 15 kilohertz, you'll get it. 1333 subcarriers. So now I can conclude things. Okay, what I can conclude is I'll compare it. So in frequency domain and time domain. In time domain, biggest element is SFN, whose duration is 10 milliseconds. In frequency domain, the biggest part is total bandwidth, whose duration is 20 megahertz. Okay, so this next break for SFN is, you can break SFN into, okay, you can break SFN into SFs, whose duration is 1 millisecond. You can break 20 megahertz into 12 subcarriers. You can call it as 1 RB. Okay, so you can call it as 1 RB. Okay, so 1 RB contains 12 subcarriers. You can further break SF subframe into time slots whose duration is 0.5 milliseconds. You can further break 12 subcarriers into one subcarrier. Okay, so instead of that, I can say 1 RB, 12 subcarriers. Reverse, same thing. Okay, and I can say here 1 RE is how much? 1 subcarrier. So here you can further divide the time slot into 7 DMA. So this is time domain and this is frequency domain. So one subcarrier is 15 kilohertz.
But one subcarrier will cover the 7 symbols.
Yeah,
So
these two you can take with respect to time domain.
but one R is just a small part of this. One subcarrier is covering the seven symbols.
Yeah, that's what I'm saying. With respect to, okay, it is with respect to one symbol. One subcarrier, one symbol. This is 12 subcarriers plus 7 symbols. These two you have to take time domain combos. These are first and last one are purely frequency domain combos. So at the end I'll draw a resource grid. Okay. Okay. So now the thing is, okay, now I'll try to draw the resource grid. So the resource grid is now something like this. So we have this is a frame which contains subframes which contains slots. Okay, which contains slots, which contains subcarriers. So 12 subcarriers, I'm calling it as 1 RB. Okay, again 7 symbols. Inside this one small part, I'm calling it as 1 RB. So as I already told you, RB is combo of 7 symbols in time domain plus 12 subcarriers in frequency domain. RE is a combo of one symbol in time domain and 1. So totally one resource grid contains one frame contains all these combos. Okay, so what all it contains? One resource grid. One resource grid contains OFDM symbols. One resource grid contains time slots. One resource grid contains subframes. One resource grid contains SFN. Okay, means all these things contain, as well as it contains RBs, it contains REs, it contains okay, it contains bandwidth. Okay, it contains total bandwidth. It contains subcarriers. It contains RBs. It contains REs. So one frame contains all these things, right? So all these things are taken into time domain. These things are taken into frequency domain. These are considered as combo. So now what is important for us? Okay. So combo is very important, right? So combination is very, very important. So now I will show you the real picture, how it looks. So try to always follow this website. Dangal LTE. So this is the resource grid, what you can see. This is the total resource grid you can see. Now you tell me, so what you can see on the top. So here we have the concept of subframe, subframe 0, subframe 1, subframe 2, subframe 3, subframe 4, 5, 6, 7, 8 and 9. So total subframes from 0 to 9. And how many slots each subframe contains? 2 slots, right? Every subframe contains 2 slots. So this 0 to 9 subframes, this 0 to 9 subframes is called as one frame. So this is one frame diagram I am showing. So this is how one frame looks. So one frame contains how many subframes? 0 to 9 subframes. One frame contains 0 to 9 frames, subframes. So each subframe contains how many slots? Slot 0 and 1. Okay. So now each slot contains how many symbols? 0 to how many symbols? 0 to 6 symbols. 0 to 6 means
0 to
7
6.
symbols. Not time wise we are clear. This is time domain. The top part is frames Okay, 10 millisecond, then subframes, then slots, then symbols. Now let us see in the frequency domain. In the frequency domain, if you see, this is the frequency domain. Okay, in the frequency domain, if you see, total bandwidth considering it as 20 megahertz. Okay, here I have taken the frame duration is only 1.4. How much? Only 1.4 megahertz. So I can even take 20 also. It's my wish. So 20 will make the picture very very big. You cannot see it. That's why I'm taking that's 1.4. I'll show you 20 also. But as of now I have taken this. Okay. So anyways, so total bandwidth I'm taking dash 1.4 megahertz. Total bandwidth I'm taking it as 1.4. Generally we take 20, but for showing it for an easy purpose I'm taking as 1.4. So basically we can have anything 1.43 okay, total bandwidth of the frame. Okay. So anyways, generally total 20 is taken, but here it's fine. So now if you see here, so this part, this red color spot is there, right? There is a spot. So this red spot, beside red spot, which spot is there? Brown. After brown, I'll show you here. I'll show you something here. Okay. So here we have a red spot, right? Then brown. After this, white, white, black. Okay, all these spots are there, right? So all these spots are there. So if you see here, this spot is red spot. This is brown, and then white, white, white. Okay. So here, if you count, okay, if you count, okay, if you count, if you count time part, this is time part. So this is the frequency part, and this is time part, right? This is the time part. So in the time part, what you are able to see is, okay, how many symbols? 1, 2, 3. So I'll show you somewhere here. So if you see from the top, you'll understand that much better way. So if you see here, so how many spots? 1, 2, 3, 4, 5, 6, 7. So this is one slot, right? This whole part is one slot. This is one slot, right? So how many symbols are there? 0 to 6 symbols. So here if you count this one, how many are there? 12. Okay, if you count it, it will be 1 to 12. So these are subcarriers. These are subcarriers. Okay, there are 12 subcarriers and 7 symbols. There are how many subcarriers? 12 subcarriers and 7 symbols. Okay, so this part is called as 1 RB. Is called as 1. This shows block. This is called as 1. So we have 1 RB something like. So now this. Okay, so if I take 7 symbols time wise, 12 subcarriers frequency wise, this is called as 1 RB. So in the same way, if I take, okay, if I take only one symbol and one subcarrier, only this point is called as 1 RE. This is called as 1 RE. So that means these small spots or small boxes are nothing but REs. These small spots are REs. Big blocks. Half of these big blocks is called as 1 RB. So we have RBs and REs. Okay, we have RBs and REs. So this is happening where? This is happening continuously, right? This is happening everywhere throughout the frame. So if you take throughout the frame, subcarrier 0, 1 RB, 2 RBs. Okay, 2 slots, 2 slots, 2 slots, 2 slots. So this is time wise, frequency wise only 12 subcarriers. Again 12 more subcarriers, 12 more subcarriers, 12 more subcarriers, 12 more subcarriers, something like that. So this is called as PRB. I'll come on to the PRB. What is this PRB? Physical resource blocks. So this is how the grid is being working out, and this is how the grid is working out. This is called as a resource grid. So this resource grid I have only shown it for 1.4 megahertz. If I make it 20, you will see a very big resource grid. Okay, so how many PRBs are there now? Frequency wise, how many PRBs? 100 PRBs. Okay, how many PRBs? 100 PRBs are there for every slot. For every slots. Okay, time wise. So they are allocated something like that. So RBs, I'll come on to PRBs, the difference between RBs and PRBs. So this is how it's a very big thing. Okay. So any questions?
One PRB is 2 time slot.
Yes.
And one RB is 1 time slot.
Yes. So this is how we have the frequency domain and the time domain. We'll come on to this part. Okay, we have actually further more discussions on this. Okay, we actually have to discuss channels and all those things. Then I'll come back to this part of this allocation. But one thing is very clear. Now we are clear about bands, bandwidth, and frames. Now the fourth thing is we have to discuss is OFDMA and SCFDMA. Okay, now the next topic what we have to discuss is OFDMA and SE. So when I say OFDMA, okay, it It is nothing but orthogonal frequency division multiple axis. So simple definition, it is nothing but it is a multiplexing technique. It is a technique to multiplex subcarriers. Simple. It's a technique to multiplex subcarriers. By maintaining reciprocal of subcarrier bandwidth. Reciprocal, this is, or you can say inverse, better word. Okay, inverse of subcarrier bandwidth. Okay, by maintaining a gap of, by maintaining a gap of inverse of subcarrier bandwidth.
The gap is known as duplex.
So again I'm writing the definition. The definition is, so we have one subcarrier, we have one more subcarrier. You mix both of them, or you multiplex or mix both of them. Okay, multiplex both the subcarriers by maintaining a gap of, what is it, subcarrier's bandwidth? Inverse of subcarrier bandwidth. A gap of how much? Inverse of subcarrier bandwidth. It's nothing but by gap of 0.6667 milliseconds. Getting my point? The multiplexing has to be done in such a way the phase difference between subcarriers should be 0.667 milliseconds. Very nice concept, right? So you know what is phase, right? What do you mean by a phase? So I'll draw you a phase. Presuming this is one wave. This is one wave. I have one more wave. So now you tell me what is the difference between two waves? This is wave number 1. This is wave number 2. What is the difference between them?
Amplitude is different. Generating from
Starting from 0 and minus.
Simple concept.
Frequency amplitude.
Simple concept. They are not traveling at same time. They are traveling at same time, but their peak points are not same at same time. Means in technical language, what I can say is, what I can say is, there is a phase difference between both the waves. So what is the phase difference? This is the phase difference. This gap. So this is becoming 0 at some other time. This is becoming 0 at some other time. So that gap is called as phase difference, right? So now that is what we are saying. You multiplex waves. You multiplex multiple waves. You multiplex multiple waves. This is called as OFDMA. So you multiplex waves, but see that they are orthogonal. What is the other meaning of inverse? See in the dictionary, Google dictionary. Okay, the other meaning of inverse is nothing but orthogonal. Okay, they are orthogonal to each other. The orthogonal to each other is they are maintaining a phase difference of inverse to their bandwidth. Get the point? They are maintaining a phase difference of inverse to their. So that way we are multiplexing the subcarriers. So I'm again doing it. So very interesting, right? So now I'm trying to write OFDMA, orthogonal frequency division, multiple axis. So that means one wave and the other wave is orthogonal to each other. They are multiplexed in, okay, they are orthogonal to each other. Means what? Means they are maintaining a phase difference of orthogonal to its bandwidth. That's why it came orthogonal frequency division multiple axis. Okay, orthogonal frequency division multiple axis. They're maintaining a time gap. They're maintaining what? Time gap of 0.667. So anyways, we will discuss this tomorrow more further on OFDM and SCFDMA. Very interesting topic. All these are very basic things of LTE of air interface. Once you understand all these things, yes, then you are good at the physical layer and all those things. Okay. So anyways, I'm ending for today. So any questions you have, you can ping me anytime. Thanks. Thanks for joining.